and welcome back to OpenShift Coffee Break. And have a coffee with us today. We have today is the Hackfest edition, and we have our co-host Andrea and Gunter and Mattia joining us today. Andrea, take it away.
Thank you, Andrea. So good morning, afternoon, and evening, everyone. So welcome to this third session of the Hackfest Office Hour, hosted by OpenShift TV Coffee Break. I want to thank again Andrea, Natale, and the whole OpenShift TV EMEA team. You are awesome guys. Thanks a lot for this opportunity. So as Andrea said, get your espresso and enjoy the show. The agenda for today is quite interesting and exciting. I hope you will enjoy as well. So we will have a quick business overview, and I'll give that overview to you. Then we will have Gunter talking about the Champ business plan for Red Hat partner ecosystem, and the technical pitch from Mattia with the multi-arc container build implemented by the Hackfest technical community. So let's see. Business is interesting to discuss, even though we always try to keep it technical, right? But today, I'm keen to share with all of you a super news. That's about the partnership between Red Hat and ABB. That's been announced a few days ago, actually, early last week. So this global partnership is actually to deliver automation and industrial software solution at scale using Red Hat open source technology, which is awesome. Now, ABB is a very important Red Hat partner, delivering automation and industrial software solution at the intersection of IT and OT, so respectively information technology and operational technology, which in the edge computing industry or space, let's say, it's crucial. It's both of them, they coexist, and they are compulsory for a proper design and implementation of edge computing solution or blueprint or architecture. Now, Red Hat OpenShift, supported by, of course, Red Hat Enterprise Linux, will now act as an underpinning open hybrid backbone for ABB industrial platform and analytics suite, enabling greater operational efficiency and real-time decision-making at the edge. So we're not just talking about architecture or workload distribution or security distribution. We are also talking about telemetry, analytics, and management of the component at the edge, both server and device layer. And that's quite important. Please stay tuned for more information. It's already plenty of news out there. We will be keen to give you updates as soon as we have something relevant. Another important piece I would like to discuss, or at least announce, is the kickoff of the collaboration between the Red Hat Hackfest technical team and the validated patterns technical team. So Red Hat validated patterns. So this collaboration is very important to give more of a business value to the blueprints we create in the Red Hat Hackfest program. You know, the Red Hat Hackfest technical team is always looking for blueprints that target verticals or business cases, but also trying to adopt the latest and greatest from the enterprise, so stable, supported, and certified portfolio. And that's not just from Red Hat, that's also from our technology vendor partners, which are technology vendors to our customers. So through the adoption of that and through the collaboration between those two technical teams, whatever we will co-create with our partner ecosystem and the technology vendors will be added to the community of the validated patterns and will be slowly certified and validated to give to that more and more business relevance. And that's the update side. So I guess I spent less than 5 minutes, which is fine. Now, I would like to introduce to all of you Gunter Harold. He's the manager of the EMEA technical partner development team, also my former manager. So I'm proud to have him here, and I'm looking forward to hearing from him. So the technical partner development team belongs to the partner development department in Red Hat EMEA. So Gunter, I would love to hear from you. What is this Champ plan about, and why is that so vital for our partner ecosystem to co-create business solutions with us? So Gunter, and over to you. Stage is yours.
Okay, thank you very much. Thank you very much, Andrea, for inviting me. It's a pleasure for me to be here. It's a pleasure for me to give you a little bit of an insight of how we are conducting planning, what the methodologies are, and where the complexity comes from. And I'm a big fan of looking behind the curtain and to remove the complexity and to think a little bit about the basics, because in the basics, we oftentimes understand that it's not that complicated and that there are a lot of patterns we can repeat over and over. So Andrea already shared that I'm the manager of the partner enablement team that he was a heavy contributor to in the past. And so the team consists of 5 technicians who are providing technical training in a manner that you as a partner or Red Hat partners can articulate their specific knowledge and interests, and my team helps to combine this knowledge with Red Hat technology. I'm sure you can see my screen, right? So I'm just want to mention the target group that we are focusing on. So it's always the sales engineers, architects, and developers. And it is heavily focusing on architects, because when you compare now the sales roles and the sales engineer roles, it's all in pre-sales, and it's all about knowing the competition, having good arguments, how to position a solution, and to find the use cases that are relevant for you as a customer or for you as a partner, of course. But from a technical perspective, and always added with this how to demo piece, because at the end, we need to show something. And we are oftentimes very in love with our technology, but at the end, I need to show something that is of value for my customer and for my business case. So there are different things that we can deliver and different ways that make sense on a journey. And Andrea mentioned, of course, the Hackfest. And the Hackfest as a part of a process is where you come together, where you get used to technology, where you are at the entry point of get to know others and to become a part of a community, which leads then that you have something, some kind of end-to-end solution, maybe alone, maybe together with other partners and stakeholders, and be able to provide an end-to-end solution for customers, which might, for example, be driven with a partner-led roadshow. On the other hand side, we have classical enablement when it's all about products and solutions that are created by ourselves. And therefore, I need proper planning. And in any case, I need proper planning. And this is why Andrea invited me to talk about Champ. I just wanted to show the context, because this leads then to a programmatic approach and to programs that help to scale. And why is that? The reason is because we have different market segments. And what you see here is from the book Crossing the Chasm. It was written in 1991. And we have different stages of customers, right? We have customers who are in a phase of, I want to be first, I want to have an advantage, and I can live with a product that is a 0.9 edition, right? It's okay if there are some flaws. It's more important to be number one in my market. And then we have the long tail, the big masses of customers who are interested in solutions that are not only market ready, but at a later stage also very much competitive, or in the long tail, so reliable and unavoidable that they say, okay, yes, now I need it too, right? And depending on which cycle you are selling to, you need a different approach. And therefore, it is vital to sit down first and to think of what is it I really need. Is it that I'm addressing these emerging needs, or is it something that I want to do to grow my business, or am I serving an established market? And in all of those cases, I need a different approach, different enablement, and different support. And so we can do this very opportunistic, of course, but we also can sit down, have a discussion on it, and put it in a plan. And this speech is to inform you very openly how we do that and how serious this is for Red Hat, because we know that we have pretty complicated pieces of technology, right? So it is important to have this conversation down to the point where we say, and here is the business case for the customer that makes sense for everyone who enters the room, right? Not only for those who also can read the command line. And so it's all about predictability. It's about strength and commitments, right? We want to sit down, we want to agree that this needs to be a win-win situation at the end, right? We want to focus on clear activities like those market segments. And of course, we want to connect our technology with a business perspective to achieve a valuable outcome for everyone. And please bear with me. There is a proper description of the process, which is not available for everyone. This is only for Red Hat partners, where you can see all the nitty-gritty details of the workshop and how this is designed. But you might think, okay, maybe there is something super special, but in the end, it is a planning cycle, and it's something where it is important to have workshops where you have good communication and good collaboration, and you're constantly keeping track of things. And this is the secret sauce. The sauce is, as always, the people who are running the process.
Gunter, sorry, may I ask you a question?
Absolutely, yes, please.
I know we have several levels of partnership with our ecosystem and also different type of partners. Is this CHAMP program available to all of them? Could you give us some more details?
The CHAMP program itself is for advanced and premier partners. But of course, no matter if it's called CHAMP or if you have another way to plan out joint activities, in any case, when we try to create solutions, when we try to team up in communities, there is always a place where we, from our supporting end, but also, of course, from our partner account management and from the teams within Red Hat, are always asking for where is the written documentation? Where is the place where we keep track of what we want to achieve? And so CHAMP is very specific for advanced and premier, but there are different lighter weight variations of it for example, for ready partners.
Thank you. I guess flexibility is the key, isn't it?
Absolutely, it is. It is, and opportunistic working is not really an option, right? And so this is where it comes from. Yeah. So what we try to achieve is that we have one process that is really consistent throughout the company, of course, to know where to connect with the information, to standardize and to give workshops in consistent quality. We also want that everyone uses the shortest path to receive the right level of knowledge. So there is plenty of trainings out there. And if you ask to become a Red Hat RHEL administrator, for example, I can easily point you to a course that lasts 86 hours, right? The question is, are you willing to spend 86 hours? Because of course you might return, well, I have some Linux experience, so let's find the gap. Let's find what is needed to catch up, and let's make this time, squeeze the time, right? This is the thing that we have the least at the moment. So, of course, we are always trying to help to find the shortest path for you to be really able to understand. Of course, it helps ourselves to be and our partners to be compliant and to have good documentation. And with a good plan, you guess it, you get good marketing support, of course, right? And so this is a process where we have some things to do internally, where we prepare properly. Then we have things where we sit down together. And Andrea mentioned it, that there is a place where we think of use cases that make sense for the market. And of course, these are then the use cases we also bring in a planning session and say, look, this is what the market is potentially looking for. How can you contribute? In which kind of variation you can make a solution or an offering for your customers out of it that is unique, that make customers calling especially you for that. So this is the one piece. And the other piece that we found is that at the end, someone needs to advertise it and someone needs to talk about it. And this is the reason why we created a format called a solution brief. This is more or less a standard, and it is somewhere between a product description and a reference case. It tells you what is on the shelf. And it's, for me, I'm very passionate about solution briefs because for me, it's always a very interesting process to not only fall in love with technology, but then to articulate in just one sentence, what is this good for? And what problem do I need to bring that this solution is capable to solve? And so it is really an end-to-end cycle that we care of, that we want to address, and where we want to help with all our experience and all our knowledge to make it easy to consume for everyone, and especially in the edge area, where it's very unlikely that you have just one party who's able to deliver you an end-to-end solution with all the nitty-gritty details. And in many cases, it's a community, a micro community, a setting of partner companies, of third-party vendors, of stakeholders who contribute to make it one solution that solves a specific issue. And so this was a quick overview to demonstrate how much we care and why it's so important for us to have this central piece of information where we gather all these things to be able to support in a proper way and to give our partners from the beginning the good feeling that their contribution and their commitment at the end definitely will lead to a good outcome and for the benefit of our customers.
Thank you so much, Gunter. That was quite interesting. And I also believe it gives our partner also the idea of how we can do, how much we can do together. So as I can see, no questions, direct questions for you in the chat. I would like to ask you a quick one, if I may.
Mm-hmm. Of course.
So the Hackvest cooperation piece brings together several partners, no? Technology partners. They could be ISPs, they could be small, super technical partners, but also technology vendors. Latest events have been sponsored by Intel, for example, and in Asian Pacific we have AWS for the hyperscaler piece. So yeah. Is the Champlan in your opinion, the natural consecution or next step for those super technical partners bringing a solution to the blueprints we create?
Mm-hmm, mm-hmm.
Or how would you validate those ideas or those components that we adopt in a distributed architecture?
Yeah, let me phrase it that way. I think it's important to understand who contributes what, and who's creating a value at which point of a process. So the Champlan makes sense if we have a joint business case and if we are addressing a customer segment, a vertical together, and we want to have predictability and we want to know how much support, how much resource we want to spend based on a projection of an outcome. Now, with very specific technical details, we might be in a situation where I say, I have someone who's really doing something super special. It's a make or break thing, but the value is the value happens somewhere else, right? So there is a value chain where I'm contributing, but I'm more or less influencing it. I'm crucial, but it's not me the plan is set up for, but I am, of course, part of a plan. And so this is a very interesting question, because this is where it's getting tricky. The chat plan itself is focused on a business partner and the business that we jointly do. But of course, there needs to be the cross connection to say who's a critical element of this plan, and to take care that these ecosystems are followed up, and that someone is taking care of these collaborations.
Fantastic, thank you, Gunter. That's awesome. That fits brilliantly into the Hackfest value propositions, and as you mentioned already, building those micro communities that help customers and big partners in solving customer and business challenges. Thank you so much, Gunter. So I guess it's time to talk technical here. Let me formally introduce Mattia. So you probably know Mattia Mashia very well, because it's not the first time he presents. We together present on OpenShift TV. But let me formally say that Mattia is a Red Hatter, a principal consultant in the Alps region. And Mattia is also an esteemed member of the Red Hat Hackfest technical community, and a great cloud native and application security expert. So he could say he's also an OpenShift expert. As a principal consultant, he's supposed to know everything, aren't you, Mattia? So, yeah.
I guess we can finish like that. It was perfect.
Yeah, fantastic. Okay. That's not for free, right?
Hi, everyone, by the way.
Let me just also introduce the topic, because it's something we really care about, and we've been working on that for more than 1 year. Mattia, myself, Ben Taliad, and other esteemed members of the Hackvest community. So the project Mattia is keen to talk to you about is called Multi-Arc Builder. So now, to give you an example, think of the need of building workload for devices or servers or components of your distributed architecture, which are based on different CPU architectures, different platforms. How would you do that on a single point? How would you use your OpenShift platform as a generator of container images? Mattia, stage is yours.
Thanks a lot, Andre, for the introduction. So yeah, that's what it's about. And also, what about Quarkus? What makes it interesting for edge device? Because they start this community about Quarkus because it provides kind of small footprint and really quick start time, which is a hard requirement for edge device. So when you start looking, a container, the first thing that comes to your mind, it's about portability, right? So I build my application with specific dependency, then I ship the container around in my environment. We don't care about redeploying patches or up-to-date. So it gives you kind of flexibility to rolling out my application anytime and without overhead. So that's why it gives you a sense of, to deploy it anywhere. But if we start thinking about different architecture like Raspberry Pi, which is a ARM device, then open a new world. So if you want to really explore the approach to build for different architecture, we can come out with 4 type approaches. So the first part that comes on your mind is to have a dedicated VM. And also that's how we start in the community. Also, Andrea start with this, his own machine, spin up a dedicated VM to try to build a Quarkus application based on ARM architecture. So if you think about this approach, it's not really flexible. Also, in case you want to automate, it's not really nice experience. And also, if you want to try to avoid to run VM on my laptop, is better. Also, because if you want to run a good machine, VM machine, you need also under the hood a good infrastructure as well. Another approach would be to use a dedicated architecture for Kubernetes, which provide all the worker node based on ARM architecture, which means if you want to specific architect, not just talking about ARM device, you need to kind of have a specific cluster for each architecture type. So it becomes quite expensive if you think about that, just for creating an image, right? And cross compilation is something nice, very attractive, of course. But the catch about cross compilation is depending of the language they use and of the type of framework. So every framework has its own way to do cross compilation, same as the language. Last but not least is device to build on device. And now we are talking about Raspberry Pi. So if you see here, that's my Raspberry Pi that we can show you on the demo. It seems like a good idea because you build it right on that device, so you make sure that your application will work as expected, although the power of that device is not good enough to do a proper compilation and think about as well a native compilation. So there is another option which the Quarkus community, the Red Hat Hackfest community explore, is to use QEMU, and which does user space emulation. What QEMU does, it allow you to run container on different architecture. It utilize a kernel component, which allow you to run various binary format type. So do you know how it works? Neither do I. No, I'm kidding. But practically, based on some identifier, it is able to understand the type of binary, and then based on the type of binary, it decides the right interpreter. So, for instance, when I want to build an ARM container device, I'll tell QEMU, please, I want to use ARM architecture. Then QEMU is going to emulate the CPU. And then it means that my build process will run under the emulated CPUs. So I'm going to use this architecture under the hood. And with this approach, allow you to not have any more the full stack that the virtual machine give you. So from the hardware to the CPU level, but with the emulation approach, it simulate the actual CPU. And the nice things about QEMU, the actual emulation takes place in container, which gives the flexibility to the developer to reuse the existing flow, which are already familiar. So it's not really a destruction approach. So you just need to use the right base image and then let the job do for you. And talking about this is fine for local environment or your local workspace, but if you want to scale out approach, you can also do this on OpenShift cluster or Kubernetes cluster, where you configure the worker node dedicated for our build to do this magic for you. And during the Hackfest, we prepare some basic image standardized, which allow you to provide easily the multi-hard container runtime image based on RHEL. And because we are using Quarkus, it's a Java framework, we provide two types of base image, one with the standard JVM builder image and the other one with native builder image. In this way, you will just use this kind of image with the QEMU enabled static binary, and then you're able to deploy your application in your device. And
yeah, may I ask you a question here?
Yes, sure.
Just to make it more clear for our audience. So you're telling me through QEMU, I cannot just build. So I start with the basic image, providing hardware emulation at the container level in a static way. So I don't need to spin up the whole QEMU instance actually. But also you're telling me I'm able to build my image being that Quarkus, JVM native mode, Quarkus native mode or Quarkus JVM mode for each and every architecture that's supported by the QEMU emulation.
Yes, correct. Also,
Fantastic.
if you think about when you run the container on your laptop, which is x86, you will see the emulation active. But when your container is running on the ARM device, is actually using the architecture of the device. So
Wow.
you
So
really
you're telling
see the
me
experience.
that works as a pass-through. I don't really
Yeah.
have the QEMU overhead or latency when I run on the target architecture. That's awesome.
Correct.
Thank you, Mattia. Thanks for sharing.
And talking about creating a consistent developer workflow, you could extend on your current pipeline, like with Tecton, to provide a cluster task which can be used by developer to build a specific architecture image. And so you can use similar workflow, not just for classic application running on a classic Kubernetes cluster, but as well application running on the edge device. And if you see on the link that we provide under in the slide, those are Git repository which help you to spin up this process on your OpenShift cluster. And what is happening is going to launch a daemon set which configure the worker node, the specific worker node for your build, and then with the right QEMU settings. So next time you launch the Techno pipeline, is going to leverage the QEMU emulation for you. So let's switch with the demo. The demo is simple. Not that the image that you see is just because it's so hot these days. So I'm really sweating right now. But yeah, so let's switch the screen. And we're going to show you on the demo the container running on the Raspberry Pi. If you have any questions meanwhile I prepare the setup, please feel.
It's funny because we were supposed to be ready for the show and you were supposed to have the setup ready. But it's fine. We can also discuss from a technical standpoint. Now, instead of having myself asking Mattia a question, let me also give you a more interesting perspective on this. Mattia shared the opportunity to create a daemon set to dedicate a few worker nodes or just one worker node, depending on the volume of compilations or Tecton pipelines you want to run on your OpenShift platform, right? That will be the starting point of build, test, and deploy at scale also for your devices. That's something we will discuss and we will propose you also hopefully with demos during the next OpenShift TV, so the Hackvest, Red Hat Hackvest office hours episodes and sessions. But that's something you can definitely think about for your customer implementation.
Cool, thanks, Andrea. We in the sample repository in the multi-arc builder demo, and there is just a simple Quarkus hello world application. The difference, we add the true Docker file, the JVM arc64, and the native one. As you can see here, we have a builder image based on our multi-arc builder, which allow you to build your container based on the QEMU emulation, and then in this way you're able to build the container for your Raspberry Pi in this case. And the same for the JVM mode. So if I switch the screen on top, you have it's bigger enough.
Sorry to interrupt you, Mattia. Could you increase the font size a little bit?
Sure. Yeah, that's what I was about to ask you.
Yes, but both on this and the IDE as well. When you get back to that.
Increase font size. Yeah, that's sure good. Okay. Maybe increase as well here. Where was it? Every time I forgot. Yeah. To me. Okay. Better?
Yeah, much better. Thank you.
Okay. So yeah, so I repeat. So maybe it's now you can see better. We have a build the image based on a native Quarkus way, and then the JVM builder image for Quarkus. And then now I'll switch on my Raspberry Pi just to make sure that I'm running on this device. I can show you kernel information. So this is Arc device. I already built the container in my machine and push it on Quay.io, but just for use case during the demo, under this there is an additional tab. This is running the container native image for my ARM device. As you see, the time it takes a little bit than expected because it's running everything under my container engine on my MacBook, but you need to kind of resize this with a good CPU and memory to make it faster. And but if you have a reach like Andrea with a bigger machine, it takes a few minutes, right, Andrea?
This is not professional at all. But anyway, we can give a few numbers here. Andrea is also kindly sharing the links to the most relevant repositories in GitHub. So you will find there the repository to build the builder image, the repository with the demo, and the repository that contains the instructions to create a daemon set on OpenShift. Now, running this on an Intel i9 or similar, it takes a couple of minutes. Okay, so the emulation is quite fast. Running the process of compiling a basic getting started for the Quarkus quick starts, it takes roughly let's say 6 to 7 minutes on a standard OpenShift reference architecture. But also we have Github Workflows to run this on our GitHub with our Github Actions. So in our GitHub workspace, and those can be read and downloaded from there is the repository called what's the name? QIOT UBI multi-arc builder demo. So we have there implemented several workflows in the modern way, in the GitHub modern way. So we have reusable workflows that show you how you can in parallel compile several versions of the same application, several versions of JVM mode or native mode, but also different architectures, CPU architectures based on your needs, on your technical needs. But on GitHub, considering the amount of resources is limited, and so usually the recommended available memory, for example, for a Quarkus native compilation is 7 to 8 gigs of memory. On GitHub, it already takes a bit longer when you have standard x86 compilations, the same same CPU architecture without emulation, and it takes a few minutes to compile with only 4 gigs of memory. Compiling an application for a different architecture and then having QEMU in place takes roughly 30 to 32 minutes, but that's limited amount of resources from both the PCPU and memory standpoint. But that works. That works, I have to say, quite nicely. We are also in a discussion. We will give you more details shortly with the Workers technical team to merge our efforts. But that's something we will probably discuss and announce later this year. Is it still compiling, Mattia? This is something we should have started yesterday. On your laptop.
No, I have already. Just I want to showcase what it does behind the scene. Meanwhile, I show the demo.
Yeah, because I guess the workers augmentation could take a while.
Yes.
Here, yeah, and I can also hear in the background the noise of your computer's fan. Is that
no? That's
struggling?
not that worker construction working.
Okay, so be careful with your computers, and they could have issues.
But good point. That is my computer. So yeah, in this tab on my Raspberry Pi, I'm running the JVM. You see here version, so I can run it right now, and it starts pretty fast. With JVM, usually it takes 5 seconds, and then let's see, 5 seconds, and then on this tab, I launch the native mode, and it usually takes, you see here, less than 1 second, so 0.10 seconds, which is really fast. What I want to show you is, you see, the native one is running natively, no issue, because it's a binary compiled for ARC64. And what I want to show you for the Java one is that actually using the JVM architecture ARM64. But the container image has been built on my laptop x86. There is a nice command to showcase. I prepared before. You can run it on your Raspberry Pi directly or inside the container, because container is a process running on your machine. Where is it? Area. You can see here. So using my JDK ARC64, my actual container. And just to check as well on the container side. Yes. Let's go to the Podman exec. Oops, minus the ID. We get the container, which is this one. Let me replace the comment before, otherwise I can do it by heart. Okay, we go in share mode. And then I run the same command, and you see here process 1, of course, and then the JVM of ARC64. So it's a real compliant container for ARC64. And
that's
of course,
actually awesome, Mattia. So you are telling us this works. So again, just to repeat it, because it helps actually. If I would create a base image and then with a layer on top that adds JVM or GraalVM or Mantle VM, whatever, for the target architecture, could that be M1 or M2 or Power, for example?
Correct.
That would work exactly the same.
Yes. Yeah, the project we show you just for ARC64, but that doesn't stop you to provide a specific container for specific architecture.
Okay, that's great. So Mattia, I kindly invite you to stop the compilation on your machine, because you're breaking up and it's draining all your resources. Poor laptop. And what I would like you to present, if you're keen to, is an overview of those GitHub workflows we discussed. So in the builder demo project, if you could go into the GitHub workflow folder on GitHub and show to our audience how we do that build, that would be awesome.
Okay, just give me 1 sec. Maybe meanwhile you can mention what will be the next step for this build, because we were discussing as well with the Quarkus engineer. Maybe we can talk about meanwhile I prepare the screen.
Yeah, that's interesting to say. So this this tool, the multi-arc builder tool, has been implemented by Bentaliard and contributed by myself and Mattia over time. But the first implementation is happened 1 year ago. This is definitely something that fills the gap between the customer needs and, technically speaking, what the Graalvm VM or Mandrill VM they are not providing, which is cross compilation, which is complex, heavy, and takes a while. So instead of waiting for our friends from Graalvm VM and Mandrill VM for a cross compilation, our friends from Quarkus community, they came to us proposing a collaboration. Now, again, this is going to be announced probably end of August, early September. But our idea is to make sure that each and every architecture is covered, when at the moment we do one-to-one, we do x86 to Arc. So we want to be able to compile Quarkus natively or in JVM mode from any source platform to any destination platform. That will bring us the necessity, the need for creating a matrix of builders, right? And of course, in turn, a matrix of base images. Because to build the image, we use our builder. To run the image, we don't use the builder, but we just use the base image that Andrea kindly shared in our chat. So we also invite our audience here to have a look, to test and try, and also to contribute if they feel like they would like to do more. That would be interesting to see how the users of the latest the latest MacBook Pro would actually benefit out of this, and if that could be beneficial for them to compile on their M processor and a container that runs, for example, on a different architecture like x86 or ARC64. That would be definitely awesome. So feel free to reach out to the community. In the blog landing page that Andrea kindly shared earlier, there are, at the bottom of the page, there are the links to our Google group, to our the link to our weekly meeting, Google Meet, and which is definitely open, and also the link to access and join our Slack workspace, where the technical community discuss usually each and every kind of technical aspect of a distributed, potential distributed architecture that focuses on edge use cases. Have you got anything to share, Mattia?
Can you see the screen?
No, I can't.
Oh.
Now we can. Okay.
This one, no.
Mattia, please share the GitHub.
Yeah, I'm sharing, but it looks like it's not really smart enough, this tool.
Andrea noted.
To shoot
Mattia, the first and the last time,
yeah.
it's...
No, I need to put entire screen.
The entire screen? Okay,
yes.
awesome.
Now you can see, and just to finish your discussion around where we are going on the Quarkus multi-arc build. I think the nice things would be tell about the next step, because we discussed, with Quarkus engineering team last time, which to provide a standard way of build Quarkus container image, and so will be also supported by the Quarkus engineering team. So based on our work, we want to do joint venture together, and so this will be the next step for this multi-arc builder for Quarkus specifically. So talking about how we do it, we leverage our repository on GitHub. We use Github Action, and we create a specific workflow to build JVM container or native container. And we can show you just the one from the ARM device, Architecture 64. You see, let me open it. So we create based on Andrea's skills around GitHub Action, and we create a reusable workflow, and then where specific parameter you can adjust how you can define the workflow. And this is a snapshot workflow. So every time you do a push, and there is going to build it and create a nightly build container. So if you're not familiar with GitHub Action, you define the job. So it means the job with the task that you want to launch, as well based on which container and the step that you want to do. For instance, here we are telling I want to check out the project, and then cache my Maven repository, because otherwise every time you launch Maven, it downloads the internet, and so you want to speed up the process as much as you can. And then you define the Java build based on specific JDK. In this case, we are using JDK 11. And then we specify where you want to push the artifact. And we are using Artifactory because we provide free to use for community the artifact repository. We build a container, and maybe this is more interesting, which I didn't show during the demo because the image were already prepared. With this command, we are telling to the container GI to be ready for the emulation. So it defines static information to your container GI, in this case running on GitHub Action, and then your container giant is ready to launch the container build for your ARM device. And this is just classic workflow, as you can see: the build application, build a container for your device, and then push it when the container is built. Push it to your container registry. In this case, Quay.io.
Yeah. Just Mattia, to add something more to the registration of QEMU static, user static. So this is completely different from using the QEMU dedicated GitHub Action. GitHub Action enables QEMU to emulate. We are just registering QEMU static to be able to use QEMU within our container to build the final image. So we're not registering QEMU on the GitHub instance. We are allowing QEMU in the container to run. So that's definitely much faster and dedicated to that process, which is easy and dedicated to the creation of multi-arc images. So that's definitely working well. Okay, for our audience, if you have any question, feel free to put them in the chat. We're always keen to give you an answer. Or guys, if you have something else to add, also Andrea, Gunter, Mattia.
No, I think that was pretty much for the demo. Thanks a lot for the audience.
Thank you, Mattia,
for listening.
That's quite insightful. So working with multi-arcs and in the edge distributed world is crucial, I believe. And also, I think that going more and more with sensors also cameras as a camera sensors as a service, like rather than smart cameras, for example. It's crucial to have the opportunity to manage workload in terms of building, updating, decommissioning also workload at specific layers is crucial. Sensors are there. The way we connect to sensors, we manage the flow is something we should focus on definitely in the near future. And that's why I believe our collaboration with the workers community, but I also hope with different languages and framework is very, very important.
And
We also
that was my question. You guys may be more aware than I am. So if this is if this is the say the roadmap, and of course, like you said, it's very important to have base images that already contain the the native frameworks pre-compiled for the target architecture. So, is there a plan to provide, for example, to provide base images for those languages? Let's say Python, for example, or frameworks like Fuse to run on edge devices for different architectures? I know it's far-fetched, but
no, it's an interesting question, Andrea, actually. I won't provide any dedicated image for frameworks. Actually, Quarkus is a framework modular with its universe of extensions, actually, and plugins. But in that case, if you think of Fuse or Camel integration, Camel K, and so on and so forth, that's still Quarkus. So it's fine. When you, on the other hand, and Mattia also please correct me if I'm wrong, when you think of language runtimes, in that case, yes, it's also interesting to have the opportunity to be able to compile final version for those languages that can be compiled, actually. Otherwise, there is no reason. I mean, Python, you won't compile that.
No, but the actual language libraries have to be in that base image.
That could be, yes, that could be. But you definitely build the image.
If you don't
directly.
compile it, you still have to have those.
Sorry, Andrea, can you say again?
So all I'm saying is I'm not, and maybe I'm wrong, but I'm not aware of. Does Red Hat at the moment have base images, let's say, for all these architectures that you mentioned, for things like the usual support languages that are supported, for example, on RHEL? So there should be, but I'm not sure if there are radius-based images. For all
they are.
Okay.
And also, as we mentioned, Andrea, we use the UBI Red Hat image, which is no arc by definition and can run on several architectures. So we use the basic flexibility of the UBI minimal images. Minimal and not micro, simply because we need micro DNF to install additional components required by GraalVM. Running
we only have a couple of minutes, but there is a question from the chat.
Yeah.
And the question is multi-arc designed, I guess, for OpenShift platforms? Yeah,
it is definitely. We have a repo, which I believe we shared. Otherwise, we will share it offline as soon as we end the session. But definitely, yes. In our QIoT repo on GitHub, there is also a multi-arc for OCP, so you can see and learn how to run those multi-arc builders on the OpenShift platform. Yes, definitely, we covered that earlier today. So shall I say goodbye, Andrea?
Yeah, we tested on, maybe just quick. We tested for OpenShift, but you can translate for Kubernetes because we use Kubernetes resources.
Yeah.
I think we use image registry, which is a specific component for OpenShift, but you can just use directly the image instead the image streams and then deploy the demo set in Kubernetes cluster. So
thanks, Mattia. So it's time to say goodbye. We will meet again next month, August, same time, last Wednesday of the month. So stay tuned and thanks for joining.
And just a reminder for OpenShift Coffee Break. Next week, we have our friends from Rung AI for our AI ML series. They'll be talking about their cool technology, about scheduling, smart scheduling of, for example, fractional GPU allocation for large scale AI and ML workloads. See you next week.
Cool. Thank you for the invite.
Thank you, everyone.
Bye-bye.
Ciao.